Hello, everyone. As the title suggests, there's a concept that I want all of you uh, to be familiar with. If you watched my previous video of me solving EGMO uh, problem, I'm not sure which one, maybe problem 3, I introduced a concept called good and bad points. And today's video is going to be exactly about that. I think this concept will improve you more in about 20 minutes time. So these 20 minutes that you will devote or not devote to this video can improve you drastically in solving problems. Like, I don't think there's anything much more effective than just listening to me for the next 20 minutes. And I truly, truly recommend to uh, hear what I'm saying and try to implement it in your own problem. So I'm going to walk you through this method on this problem. And I really, really advise you to use the same approach on easier problems that you will do in the next 7 days. So try this method, and I promise you, it will help you. I'll begin. We start with the problem, and as we will go on, I'll explain the method. So we have a triangle ABC, and in this triangle, AA prime is the diameter of the circumcircle ABC. On the extension of AA prime, we choose an arbitrary point E, and we draw a 90 degrees angle from there, a line at 90 degrees, which intersects BC at point T. TP is the tangent to BC, to ABC, the one that lies in the shorter arc BC. And then we draw a line AP that intersects this line at Q, and M is the midpoint of this AQ segment, and TM intersects sides AB and AC at points X and Y, and we are asked to show that MX equals MY. Now, what is the actual concept that we'll introduce? And the concept is called good and bad points. Well, we will even extrapolate this concept by saying good and bad lines, good and bad everything, so good and bad elements. However, uh, right now I'll explain how it works. So let's look at this diagram. A good point we will define as a point that is nice, that has some nice properties, and that can be easily um, used, properties of which can be easily used. For example, in triangle ABC, A prime is a good point, and so are A, B, and C. And for example, point E is also good, it just lies on A prime. Now, point T, it's not completely bad, but we don't know that much about it, so it does have some properties. For example, AET equals 90 degrees, but we don't know how to use it. And point T, I usually call a filler point. So what happens in most problems is you have a starter pack, which is basically your ABC, orthocenter, incenter, whatever, midpoints, sides. And then what's going on, you have some filler points. So a filler point, it is used, it's neither good or bad point, but used as a branch or a bridge between good and bad points. So what are bad points? Bad points are points that we don't really understand, that we don't know the structure of which, and that are not really related to the question. So what I'm talking about is, for example, point Q or point M. We have no idea how do they directly relate to ABC. So it's hard to make any um, predictions about them. So the way we always find problems or something hard in a question is we don't know how to use certain properties. So by the time you learn all the theory needed for geometry, you pretty much can solve anything if all the points are related to each other quite nicely. The problem comes up if you have, say, such a segment as TM that intersects AB and AC at point X and Y, and these points are pretty random, so you don't know what to do with them. And that's the main problem in geometry. And with this understanding, I'll show you by logical steps how to actually deal with these problems and how to logically think about them. And it might not sound as something very, very out of worldly or something that'll break your mind, but this is the basic thing, how to improve by like 200% in just 25 minutes. I swear. This is the core method that you will need to use to solve hard questions. This is the method I use. When I don't know what to do in a problem, this is what I do always. And this method will help you to solve so many problems. It's such a basic, easy thing to do that will improve you by much more than if for the next 25 minutes you learn a new, I don't know, theorem or anything else in geometry. Trust me, the next 20 minutes or 15 minutes, this will improve you much more than anything else. So pay attention. And I'll start us off. So bad points are points that we don't understand. Good points are points that we do understand, and filament points are the bridge points between the bad points and the good points. Okay, how do we get to any problem? Well, any problem, the solution to a problem is basically starting off from a good point and then going to filament points and uh, basically finding some nice properties to them, relating them more to the good points, and then from good points relating to the bad points. And when we do that, all the points start working together. The way we connect good and bad points is we find some nice properties. And there are two major ways to do things. First way to get rid of the bad points. So um, we can try to uh, add some other points that will make this point nice. For example, there's a traditional example of triangle ABC, circumcenter, circle, MH, and then MH is intersected with the circumcircle at point Q. And Q is now a bad point because we don't know anything about it. Well, the way you can make the Q a good point is you can add these lines and then this will be one circle. Now it's much better, it's much useful, it's much more natural to look at point Q. And now it's not a bad point because we added, say, these 2 points. So the way you can get rid of bad points, and every problem is basically breaking down the bad points and making them to good points. Or the other thing that you can make is get rid of it. And the way we get rid of a point is we try to um, restate what this point works for with other conditions. So say if you want to prove that some, I don't know, some random segment is, I don't know, twice as less than the other segment. And the way we phrase it, and there are two bad points, and you somehow can get rid of those bad points and reframe the condition of this segment being equal to some other segment between the two good points, you're deleting these points. So we'll have two methods that we can use to get rid of bad points, add good points that will interconnect them. So we add filler points to connect good points and bad points. That's method number one. And method number two, what we'll use is we will get rid of them completely. So we ignore all the we use the conditions and we try to get rid of these points. That's what we're going to do. So let's look at this question. And so from start, we know that X and Y are bad points, M is a bad point, and the way you approach these problems is you try to start from easy stuff. So in every problem, you shouldn't start to guess what you're trying to do later and try to guess how to one line solve the problem. What you actually want to do is start from easy stuff. So start, say, from good points, T, E, Q, something more connected, and then move on from harder to harder. Like in video games, you don't go straight to the final boss. You go, you upgrade, upgrade, upgrade until you can reach that level. So for now, let's forget about points X and Y and M and just focus on P and Q. And the way you approach this is you try to find some nice properties. So in this case, if we try to find nice properties of P and Q, we can start to chase angles, right? So that's one of the methods we can start to approach some easier stuff. Oh, okay. For example, we know that this angle, if we connect P and A prime, right? If this angle is, say, alpha, then we know that this angle is 90 minus alpha because we have a 90 degrees here. Similarly, we also know that P and A prime is the diameter. So this is 90 degrees, and this was a tangent, so this is alpha. This means that angle APT is 90 plus alpha. And if APT is 90 plus alpha, then this one is 90 plus alpha. This gives us TP equals TQ. And now let's think about the problem more conceptually. So the way I always advise people to solve geometry is to think about geometry as a problem, as a set of conditions. So if you don't know a good or bad point, you need to look at the conditions that are given and what step by step look, okay, how can I use this condition? How can I use that condition? And that's how you start with every question basically. So here we had a tangent TP, it is equal to TQ. Now, what's the problem for me with that? Well, I don't have any problem with that, but it's kind of awkward that we have only one tangent and we don't have the second one. So there's a good reason why we want this tangent to be and not the other one. So since we already have TP equals TQ, there's an idea that we should draw this circle TPQ. So we can add this point L, and we can say that TL is a tangent. Now, after I teach you this method of good and bad points, try to practice it, but also try to think about geometry problems the same way you think about combinatorial or number theory problems. Just try to think about it logically. So, how can I progress from some point? What point? Why is there one tangent? Just ask yourself logical questions. Again, but so far we don't get anything else. Now we can look at the bad points, right? So we have a point M. So we now kind of understand point Q, point P, and point T, but we still don't understand point M because M is quite random compared to other ones. It's a middle of some random segment. So what methods do we know that can relate a midpoint? So there are two things that we can do with the bad point, which is point M. We can either get rid of it or we can add some other points that will make this point look more nice. Okay, you can pause the video and think what's the best option here, but here's my point of view. If we delete point M, we'll have to get rid of points X and Y. And the segment TM, it's quite hard to replicate or rephrase the condition that mx equals mi equals my in any other way, just because of it's basically a random line TM through a random angle. So there's not much you can do about that. So this brings us that M might not necessarily be the point that we want to delete. Okay, so the other thing that we can do to this point is we can add good points. Okay, how do we make midpoint a good point, a better midpoint of a random segment? And but the answer is pretty obvious. The only way, or one of the maybe only ways you can make midpoint probably more nice on the diagram is add another midpoint that'll make like a midline. So, and in this case, we have AA prime, right? We have AA prime. And the midpoint of AA prime is nothing else than the certain center. So if we add O, O is the midpoint of AA prime. And if O is the midpoint of AA prime, then we know that OM is parallel to A prime Q. Well, we want to show MX equals MY, and we have the O. So there's a chance that after this, somebody might notice that maybe, just by chance, OM is perpendicular to XY, and OM is the perpendicular bisector of XY, and this will solve the problem. Okay, and when you come up with such sort of statements, you always want to check them. And the way we check them is just by brute forcing it. Like you can test on different diagrams, and if it kind of looks okay, go ahead, test it. So we were just going to test the waters and say, okay, let's suppose OM is perpendicular to XY. Uh, so what would that mean if that was true? Well, if that was true, then A prime Q is perpendicular to TM, right? But TM in of itself is not a very good point, well, a very good line, because we don't know anything about point M. It's not really related to point T. So to prove that A prime Q is perpendicular to TM, this statement is hard to prove because T prime M is a bad line. A prime Q we can kind of refute. So what do we do with a bad line? We either get rid of it by rephrasing, or we add something else that makes this line nice. Okay, now let's make a choice. Do we leave this line and add some other points and rephrase the problem, or do we delete this line and we focus on something else? The right answer here is we get rid of this line. The reason why is because point M, it just doesn't work with points A prime and Q. So line T prime M, it will never, ever, ever work with points P and Q, just because TM is like a median. So the way you get better at feeling this stuff is you just practice. So in this case, what we will do, and the logical thing to do, is we want to rephrase line TM. We don't want it to be the line that we try to show is perpendicular to AQ. We want something else to be the main driving force. And obviously, if you reflect Q over T and get a point Q prime, we again use the same idea of midpoint. If midpoint is uncomfortable, use the midline rule. So we'll just show that when we reflect Q over T and get Q prime, then AQ prime is obviously parallel to MT, and we just want to show A prime Q is perpendicular to AQ prime. And this is much better. This is so much better than TM. Uh, okay, so what do we do next? Well, we see that there's the strange, weird thing that this is one line. Well, and we try to show it. And here it comes already your knowledge. So here, the actual way to show this is we have to understand that if A prime Q is perpendicular to AQ prime, so you assume it's true and then you find some statements. So then this will be one line because A prime is the diameter, so ALA prime is 90 degrees. And if that's true, then QL, AE, and then hence Q prime P will be heights of triangle AQ prime Q, and T and M will be its midpoints, right? And what do we know about that? Well, Euler lines, or Euler circle. Well, M, P, E, T, L, O, because it's the midpoint of A prime, lie on one circle. And this observation will actually help us. So the way it actually helps us is that forget about all these lines, right? We know that OM, well, say M, P, we want to show like some cyclic stuff. So if we look at triangle AQ, Q prime, well, M is the midpoint, right? Then we have a point E, which is the foot of the height, and then T is the midpoint of Q prime. So the circumcircle of MTE is basically the Euler circle. Well, if that's true, if MTE is the Euler circle, then we want to show that P lies in the circle. So we want to show MTPE is one circle. Um, but what we do know is that OPT was 90 degrees. So PET and O, they also lie in one circle, and so does L. Well, we just want to show that this is one circle. Well, MP and then E, they form the Euler circle. And now what we want to show is that point T, well, it's as a midpoint. We want to show that also points O and L lie there. Well, we know that OLT and OPT and OET, they're all 90 degrees. So we do know that OETPL is one circle. But because we knew that MPE is the Euler circle, and we do know that MPET is basically, if we look at this one and we just count angles, so we just know that if L is such a point on the circle, then this is 90 degrees because it's the diameter, as we said. Then what ends up happening is that we don't know yet that this is one line, but we do know that A prime is basically the foot of the height. So if L is such a point that's intersection of QA prime and the circumcircle of ABC, then if we redefine point Q prime, not as the section of Q, but as the intersection of AL and QT. So if we define stuff like in some other way. So another thing about geometry is you often want to try rephrase different stuff. So if we rephrase as AL intersecting QT at point Q prime, then we do know that basically A prime is the circumcenter, right? Is the orthocenter of triangle AQQ prime because this is the height and this is the height. And then you have M being the midpoints of AQ, L being the midpoint of AA prime, and then we also know that this is the foot of the height, this is the foot of the height. So therefore, by extension, this is the Euler circle, and then this is the midpoint. So just by looking from a different perspective, we just get an additional claim. So if sometimes you can see that it's not going anywhere, you have a lot of claims, but you don't know the exact order, just try to flip the order around how you do them, and that might help. So in this case, that did help. So we got that basically this is all cyclic, and we got back that this claim that TQ equals TQ prime. So now we have all that, and the question is what we do with that. Well, we do know that this is 90 degrees, and we just showed also that this is 90 degrees. So what happens now is that we want to show that it's 90 degrees, but it's normal. So we need to show OX equals OY. And here are two ways to go. The first thing that I thought about is like, okay, maybe you should show that AX times XB is AY times AY times YC, and that will finish up, but that didn't work. And as general advice, don't spend too much time on just one idea. Try to test different stuff. This will always help you. And I didn't think that it was going anywhere, so I looked at it from a different angle. Well, what we actually want to show is that OM is a perpendicular bisector of XY. But we do know that OM, because XY is parallel to AL, we do know that AL, perpendicular to AL, the perpendicular bisector passes through O and is a line perpendicular to it. So OM is actually the perpendicular bisector to AL. What does this mean? This means that AXYL should be an isosceles trapezium. And that might not seem useful. However, the ones that read my close article, those will know that then because this will be cyclic or shouldn't be cyclic, the immediate reflex is that L is the middle point of EXYC. And I can't make this sounds less important, then just when you see mickle points, do not ignore them and actually make sure you're comfortable with solving problems using mickle points. That is very useful skill, like very useful. It's very underestimated, but it will help you so much. So if you're not very good at mickle point, like spend a solid day or solid time just trying to understand this concept. It's actually very important. Okay, so we just want to show that this is cyclic. But we don't need to show that now. So we know that AL is parallel to XY. So if we show that XYL is cyclic, then we're done because AL and XY will have the same perpendicular bisector, which is ON. But now we just want to show that, so the condition that AXYL is a bad condition. We don't know how to show it. Like you can't really angle chase it. So again, we have a bad condition and we have a choice to make. What do? We either get rid of this condition and rephrase it, or we find, for example, another point on the circle and try to prove some other cyclics, and then it will work. In this case, we'll choose the second condition. Why? Oh, the first one, sorry. The reason is we know that XYL, if the claim that it's cyclic, it's the same as L being the middle point for BXYC. How does this benefit us? Well, the middle point, it has so many options to go to. You can show different cyclic quadrilaterals. You can show that Lx times C is Ly times Lb and still get it. Like there's just from middle point, there are a lot of ways to approach the problem. So in this case, if we show that, for example, PXLT is cyclic, then we're done. And the reason we're done is because then this will be the middle point. And if it's the middle point, then XYL is cyclic, and then we do know we're done. So if this is cyclic, we want to show that. We just want to now count angles. That's it. And how is this angle chase? Is you just need to look at carefully what angles are countable, which ones are good enough to be counted, and which ones are not. And for example, if you look at this angle, it's not bad because we have this line being parallel to AQ prime. So it is the same as this angle and it's the same as this angle. So this is X, this is X, and this is X, this is X. And we're trying to get to angle XBL. So we want to get to this angle, XBL. Well, an XBL is also a good angle because it just looks on this arc of circumcircle ABC. So this angle is the same as this angle. And we know that A prime Q is perpendicular to XT. So this is 90 degrees. So because this one is X, this one is X as well. And this one is equal to this one because here's 90 degrees and these two are equal. And in this way, we're done. We are done with this problem. Uh, I hope that this concept was understandable. And I highly, highly recommend you to try it and solve easier questions, like actually easier questions, and think through the logics, through the mechanics of this thing. So don't start with solving G7s, trying to, okay, now I know this method, let me try G7 or G5. Try some G1s, G2s, or something easier that you know you can do, but just try to use like this method. First time you can prioritize deleting points method. So just spam, for example, okay, how do I rephrase this condition? This, okay, why this point is bad? Okay, it has two conditions, for example, intersection of line XY and line TU. Which one is a bad line? Okay, XY is bad, TU is okay. How do I rephrase line XY? And you continue, and just do that for a week, and I promise you, your levels will go so much higher and you'll be so much better off the bat just from one video. And yeah, I mean, please let me know how did it go if you found that useful. So I'd be really happy if a lot of people found that useful. Personally, when I discovered this maybe in like 5 years ago, 4 years ago. He helped me a lot. So I hope this was useful to all of you guys, and thank you for all the support, for the subscribes, likes. I appreciate that a lot, and thank you. I know I promised to do a board video. I'll do it later this next week. I'll do that. I just need some prep materials to do that. But I wanted to do a quick video on these concepts, and I hope you found that useful. So thank you everyone for watching, and God bless. See you in the next videos.